Okay, guys, Zachariah J here again. IVC Precalc Chapter 3 and 4 Exam Review, Part C, the final installment for this test. And this is our sample questions 30 through 36. So I'm going to go through the last of it. And just as a reminder, I'm not an instructor, I'm just a student, so I may make mistakes. Don't substitute this video for doing practice on your own. You really need to pick up the pen or pencil and use some paper, or like I do on my iPad, just practice going through the problems. Even if you're doing the same problem over and over, just you got to practice. Otherwise, you're not going to probably do very well on the exam. So anyway, without further ado, let's get on to the last 6 or 7 problems here. So number 30, solve the inequality. All right, well, we actually need to move this 20 over, so we have 2x squared plus 3x minus 20 is less than 0. So we want to know all the part of this that's going to be less than 0. Let's fix this x here. All right, so we're basically going to have a parabola that opens up, but let's see if we can get this factored down. So 2 times 20 is 40. So that's 8 and 5. 8 times 5 would give me 40, and that would also, yeah. So 2x squared plus 8x minus 5x, that would give me my 3x minus 20. Now I can factor out a 2x. So 2x gives me x plus 1 minus 5 times the quantity x plus 4. Sorry, before that was x plus 4 as well. uh, 2x minus 5, and then I get my 2x plus 4's, so that's times the quantity x plus 4. So there we go. Totally factored out there. This means I'm going to have a x equals minus 4, and then I set this side to the equals 0, which is going to give me 5 over 2, but just do the work here and show you how you get that. 2x equals 5, and then x equals 5 over 2. So my other x value is 5 over 2. Do a quick graph here. Just kind of show you what we're looking for. And it's not perfect, but see what we can do here. We'll call this negative 4, and we'll call 5 over 2. That's really 2.5, so call that here. Now remember, this is a positive here. It's not a negative, so our parabola opens up. I don't really know where the vertex is. Don't really care. This problem just is concerned with whatever's below the, let's make this green, whatever's below the x-axis here. So problem's just saying, when is this um, less than 0? Well, originally it was less than 20, but we moved it over. So, and that happens between negative 4 and 2.5. So, or 5 over 2. So there you go. That's all this problem's looking for. It's pretty simple. All right, this one gets a little more complicated. So we're gonna have to do a little bit different technique on this one because it's an irrational fraction. It's a pain in the ass, but we got to deal with it. So obviously we're gonna have an x equals 0 from the x squared. This is going to give us a 0, putting in a 12 here, and putting in a negative 2 here is going to give us a 0. And then in the bottom, now I'm going to put a line here because I want to separate these out. In the bottom is x equals 6 will give us a 0. Well, it'll give us something undefined actually. And negative 9 will also do the same. The reason I separated these out is because this section will not be included, right? Can't include these numbers in our strings of things that are greater than or equal to 0. These are basically our vertical asymptotes, so uh, we can't include them, basically is what I'm saying. So we'll draw out our number line here. Straighten this guy out. Put some numbers on here. I'll try and put them in order. They didn't come out in order up there, so take me a second here. 12. So that's all 1, 2, 3, 4, 5. Yep, 5. So I got to pick a number below negative 10. So I got negative, or below negative 9. In between negative 9 and negative 3 is 3. In between 1, 1, 10. I'm trying to pick easy ones, 14. Um, and so basically, what I'm going to do is get my original uh, equation here. Just going to recopy it down over here. And all these test values that I wrote above my number line, I'm going to just enter those into my function here, or my equation here. And I really don't care what the answer would be. I just care if the answer is going to be positive or negative. So if I put negative 10 here, I'm actually going to get 10. It's going to be positive. Put negative 10 in here, I'm going to get a negative. I put negative 10 in here, I'm also going to get a negative. Um, so positive times a negative equals a negative. And then this last section, if I put a negative 10 in here, well, that's going to end up being negative. Negative times a negative is going to be a positive. So for the top half, if I put in negative 10, I'm going to get a positive. The bottom half, however, I will work that out. Negative 10, that's obviously minus x is going to be a negative. Negative 10 in here, that's still going to be negative. We get a positive. Positive over positive means this section will be positive. All right, so just take all this out. Now let's pretend we're putting in negative 3. So negative 3 squared is negative 3 right here. That's our test value we chose. We could choose any value between negative 9 and negative 2, but I chose negative 3 just because. So for squaring it, it'll be positive. Put it in here, it'll be negative, and here negative. So that means I'll have a positive across the top. On the bottom, negative 3, I'll get a negative out of this part, and I'll get a positive out of this part. So I'm going to get negative on the bottom. So this will end up being a negative. So I'll just put negative underneath the negative 3. All right, so I'll do this again for negative 1. Negative 1 times negative 1 is going to be a positive, obviously. So just put a plus here. Negative 1 in this section is going to end up being negative. Negative 1 in this section will be a positive, so I'll get a negative on the top part. Looking at the bottom part, I am going to get a negative and a positive, so I'm end up with negative on the bottom. So negative over a negative, well, guess what? It's a positive. All right, keep on keeping on. We'll put 1 in there. Um, 1, that'll get a positive, obviously. This is going to be negative. This will be positive, so the top will be negative. And then in the denominator, I'll get a negative and I'll get a positive. So I'll get negative for the denominator, negative, negative. That means positive. So for this section between 0 and 6 is going to be positive as well. Going back through, we'll look at 10. 10 squared is 100, but don't really care about it being 100. We just know that it's going to be a positive number. That's what we care about. Here it'll be a negative, and here it'll end up being positive. So I'll end up with a negative in the numerator. In the denominator, this part's going to be still positive, and this part will be positive. So I'll get a positive. So this will be a negative part of the fraction. So underneath 10, I'm going to put negative. And then one more time with feeling this time, right? So 14 squared It's going to be positive. This will be positive. This will be positive. So we get a positive here. This will be positive, and this, of course, will be positive. So all positive. So positive, positive, positive. All right. So now I need to write um, negative infinity to negative 9. But this is the important part we have to remember. We can't include this, so it's because it's a vertical asymptote. So, and then union, where else is it above the x-axis or above 0? So it starts again to be above 0 at um, uh, -2, but we're including that because it's on this side of this vertical line I made. That number came from the numerator, not the denominator. And it goes to 0, which also came from the numerator. That 0 came from the numerator. But it also goes all the way to 6. So from 0 to 6, it's also positive. So, but 6 was from the denominator, so we can't include that. So we have to do a parenthesis. And then the union symbol, and then we get to 12, which came from the numerator, so we include that, and it goes to infinity after that. So that's our answer for 31. Kind of a long, drawn out trial and error process. I hate problems that have this kind of thing, but it's kind of the necessary evil for this problem and also for this next problem, and then for the next problem and the rest of these problems. But anyway, so here we're going to obviously move that x over to the other side. So we get 2x over 7 minus x and then minus x for that whole thing. And then we want to get common denominators so we can turn this into just one giant mess. So we got 2x minus x times the quantity 7 minus x, and that'll be all over 7 minus x. Started out to write this as two fractions, but I figured I'd just condense it really quick. All right, so now I got to distribute that x into the quantity. So I got 2x minus 7x plus x squared over 7 minus x. All right, so can I factor this top piece? I can move all this kind of stuff around or do something. Well, actually, I can't factor it, so but I can combine like terms. Negative 5x plus x squared. Now I can factor out an x. Yeah, so I'll get x times the quantity negative 5 plus x all over 7 minus x. And this, of course, all of this is supposed to be greater than 0, which I should have written that for all of these coming down, but really, we just know that that's the case, right? So now let's figure out what my zeros are. Well, I'm going to have a 0 at 0 because that first leading coefficient, or that leading term x is, if that was 0, that would make it 0. Put in a 5 in that quantity piece, negative 5 plus 5 is going to be 0, so that's a 0. And in the denominator, 7 minus, well, 7, that's also going to be a 0. So draw my number line, put my 0, 5, 7 up here, make this one 0, this one 5, one more, make it 7. Now I need to pick some test numbers. Negative 1, 1. There's only one between 5 and 6, so, or 5 and 7, it's 6. And then I'll pick 10 for, because 10 is easy to work with, above 7. So I get my equation that I kind of simplified. And then remember, I don't care when I put in negative 1 what this actually equals. I just care if it's negative or positive. So put in negative 1 here, it's negative. Put in negative 1 there, I'll get a negative. So I'll get a positive on the top. Put in negative 1 on the bottom, I'll still have a positive. So this portion from negative infinity to 0 is going to be positive. So now I'm going to put in 1. Well, that's positive here. This will still be negative, so I'm going to get negative on the top. And this will still be positive on the bottom. So this is going to be negative for this portion of the function. I don't know. This isn't a function, I guess. I mean, it is a function, but I don't know. It's getting late. What time is it? 12:30. Holy smokes. All right, 6. That's going to be positive. That'll make this positive 1, and this will still be positive. So this portion will be positive. Put in a 10, and we're going to have positive, positive. So the numerator is going to be positive, but our denominator is going to be negative. So this whole section is going to be negative. So now I need to write where it's below the number line because of this thing. I want to know when it's less than 0. So 0, um, not including, of course, all the way over to 5, and not including that. I'm terrible at drawing these little squiggly things. So I want to know these sections here. So 0 to 5, but not including those numbers, and then union, and then 7 to infinity. So that is our answer for this guy. Kind of a long, drawn out process, but not nearly as long and drawn out as what we are about to experience with this guy. Use the rational zeros theorem to find all the real zeros for the polynomial functions. Use the zeros to factor f over the real number. So I just want to look at the leading term and the final term, and I'm going to start making a list here. Now my factors of 4 are 1 and 4, and then obviously 2 times 2 would make 4. So my factors are 1, 2, and 4. So I can use a plus or minus 1, plus or minus 2, or plus or minus 4. That's how I figure out what I get on the top part of this here. And then I look at my leading term, which is 3, and its factors are 1 and 3. That's it. So I can use a 1 or a 3 on the bottom. So if I divide all those top pieces by 1, I get plus or minus 1, 2, or 4. I'm lazy, so I'm going to, instead of writing plus or minus 1, plus or minus 2, I'm just going to do this squiggly, and it's going to be kind of this set of all these things. Plus minus 1, 2, 4, 1 over 3, 2 over 3, and 4 over 3. All right, so these are all the pieces that I'm going to need to test in this next division thing that I'm going to show you here. There's some fancy word for this type of divisions, like short division, or that doesn't sound very fancy, but I'm sure there's some name for it. I can't remember what it is, but I'm basically going to take the coefficients of each of these terms and I'm going to write them down here. So 3, negative 5, 8, it's positive 8, negative 10, and positive 4. And I'm going to make a little upside down division sign. And then I'm just going to use the first number that I had. I have plus or minus 1. So I'm going to divide by this division by 1. I just bring this 3 down here. So 1 times 3 is 3. Add those together, and I get negative 2. Now I'm looking for 0 by the time I get to the end somewhere here. So 1 times negative 2, this is add this negative 2 to 8. So I get 6. 1 times 6, bring the 6 up here. I get, that's going to be negative 4, and then 1 times negative 4, and lo and behold, this is a 0. So what this means is 1 is a 0 in this polynomial. So this is one of the zeros one of the real number zeros. So 1 is a 0. So to make a part of the equation, it would be x minus 1, the quantity x minus 1. If I put 1 in that, that would equal 0, right? All right, well, we found the first 0, so now I'm just going to use what remains, and I'm going to try negative 1. And of course, I bring this 3 down again. So I get negative 3, add those together, and I'm going to get what, negative 5. And then that is going to be negative 1. Kind of did that a little wrong, but I know this isn't 0 anyway. So that should have been negative 1 times negative 5 should have been 5. But anyway, that wasn't going to work out to 0. So I'd move on to the next one. So 0. Oops, why am I erasing that? That's done. The positive. Now let's move on to positive 2. Um, and we keep going through this blah, blah, blah. We keep testing every single one of these. It gets really long, tedious, and monotonous. But and for the sake of the video being shorter, I'm just going to tell you that I've already tested all these, and they do not work. But we have 2/3 here. Let's see what happens when I use 2/3. 2/3 times 3. Well, that's going to give me 6 over 3, which is 2, right? 6 over 3, that reduces to 2. So put 2 here. That's going to give me 0. And 2/3 times 0 is 0. So that brings down to 6. And then 2/3 times 6, that's going to give me 12 over 3, which is going to give me 4. 4, that gives me 0. Oh my gosh, I found another 0. So 2/3 equals is a 0. So basically that would be x minus 2/3 would give me a 0. Another way you could write that is 3x minus 2. That's the same thing. I'll let you guys do that as extra credit for yourself to figure out why that is, if you don't remember. But I still have this remaining stuff, this 3, 0, and a 6. What am I going to do with this? I know that the rest of those aren't going to make this factor out to a perfect 0. So my polynomial started with an exponent of 4. So this top line was the 4th, and this line was the 3rd. So that means this line is the 2nd. So what that means is what I really have left over here is 3x to the 2nd. And then I have 0 here, so that means I don't have any x to the 1st. And then I have a positive 6, so just plus this 6 here. So that's what I really have left over using this technique. So while this technique is really long and tedious, it's much shorter than if we would have figured it out from that big number. I got to this point, I'm down to just these 2 terms, and I can figure out that for sure, just to double check, I'm going to get negative 2, and then, of course, x equals plus or minus the square root of negative 2. And sure enough, since I have a negative under the radical, that means this is going to be imaginary, an imaginary number. So, and remember back in our directions, we want to find all real zeros. So this is just a little check here. I checked through, and yes, indeed, no more 0. So basically what that means is if I take this, x minus 1, I take either one of these guys. I'm just going to take this one, x minus 2/3. And then I'm going to take my 3x squared plus 6. And that is my simplified function here. So, but I should factor out this 3. So I'll do this 3x minus 2/3. And then this ends up being x plus 2 because I factored out that 3. So this becomes a 2. So this is our final answer here. So that's number 33. Number 34 here. Um, going to solve the equation in a real number system. So basically, I'm going to just do the same crazy little division thing that I showed you just in the last problem. So here's my factors for my leading and end um, uh, terms. Creating my list of numbers to try, obviously 1 and 5, and then 1 over 2, and then 5 over 2, and then plus or minus of all of those. Now, in the interest again of keeping this video short, I'm going to go straight to what I think is going to give me the quickest answer. Normally, you're going to have to just go through all of these, but I know 1/2 is where it's at. So just put 1/2 here. I mean, I'll show you 1. I'll show you number 1 just to prove it out here. This isn't going to give us our 0. And that's going to be -4. So sure enough, not 0. Might as well just do -1. I said I was going to make the video shorter, but then here I am. Just maybe it's more. Maybe I should be honest. I don't trust myself. Yep, not 0. All right. So I did the 1s, 5s. 5 times 2 is 10. That's -9. -9, that's going to be -45. Add those together, it's going to be, well, you can see that's going to be -55. And -55 times 5 is going to be a huge number. It's obviously not going to get 5 to be 0. So I can see this is going a bad direction. So I need to go to this half. So half times 2 is 1. That makes that 0, 0. -10, half of -10 is -5. Oh my gosh, sure enough, there's our 0. Now remember, this was our third up here, and this is going to be the second. So that means we have 2x to the second, and minus, well, it would be 0x minus 10, but since this is 0x, we don't write that. So we have 2x squared minus 10. And where's our other x going to be? Well, let's just solve this. And then divide that by 2. That's going to give me 5. And then I'm going to get plus or minus square root of 5. So solve the equation for in the real number system. I get these 3 values technically, but I'm just going to write them as 2 because I'm cheating by putting the plus or minus in front of the square root of 5. That's really square root of 5 or negative square root of 5. Anyway, there you go. Number 34. And number 35 is exactly the same problem, except for we're going to solve it the same way. So 8, I get 1 times 8, and then 2 times 4, and then 2 times 2. Those are all my factors. So 2, 4, 8, and 1. So that generates my top 1, 2, 4, and 8. And the factors for 3 is 1 and 3. Doing my little cheater step here. Again, 3 and 1. Just show you where I'm getting these. 3 and 1. And so I get plus or minus 1, 3, 2, 4, 8, 1/3, 2/3, 4/3, and 8/3, of course. Yuck. That is a lot of test values to plug through this. But we got to do it. So we got our leading terms here. We got 3. negative 17, we got 18, and we got 8. And we're going to divide that. We're going to start with bringing down this 3. And you'd start with positive 1. But I'm just going to skip to 2 just to save time. I'm really going to save time this time. So 2 times 3 is 6. This means this is negative 11, negative 22. That leaves me with negative 4, which gives me negative 8, which gives me 0. And my pen catch the negative, whatever. That is 2 times negative 4 is negative 8, so 0. We found our first 0, so x minus 2. This is the third, this is the second. So we can write this out as 3x squared minus 11x minus 4. Is this something we can factor? I think it is, because we can do plus 1 minus 12. That would give me 20. That would give me 12. And that would also give me minus 11. I think. I'm so jealous of people that can see these just like instantly. So 3x squared plus 1x minus 12x minus 4. And yeah, minus 4. So now got these, so I can factor out an x here. And plus 1. And, oh, wait a minute. 4. 3x. What have I done to myself here? Oh, I can only factor out an x on the first part because, yeah. X. Here we go. Now we have 3x plus 1 minus, and then we have 4, and that's going to be 3x plus 1. There we go. So now we have x minus 4, and then we have x times 3 plus 1. And then remember, we had our first 0 that we found up here, which was x minus 2. So we have to put that in our dealy mahoo, or in our lineup rather, down here. So x minus 2. So now we find our zeros here. 2, 4. Remember, before I was like, this will be extra credit. Why does this work out to x minus negative 3? Well, here's the work. Kind of showing you how this ends up being this way. So there you have it. We get negative 1/3 out of this. If you did that in the reverse, you would have figured that out on the other one. But we get negative 1/3, 2, and 4. That is our answer here. And then on to our last one. Find a bound on the real 0 of the polynomial function. So really what we're trying to find out here is if we had a function and we graphed it, how far to the left would it go and how far to the right of the y-axis would it go. And so we're going to do this, but we're going to do this division thing, but you'd start at 1 and you just use full numbers like 1, 2, 3, 4, 5, 6, all the way to infinity. I mean, until you found it, but really you shouldn't have to go much past 8. 8 might be the max. Maybe it's 5. I don't know. You just, if you haven't found it by then, you should probably use a different method, which we'll get into later, I suppose. But here we go. 1 times 1 is 1. Those together is 5. 1 times 5 is 5. So that's 8. At 8, this is 10. 10. This is going to be 7. And this is going to be, wait, why did I put a negative there? 7. Getting all crazy here. 7. And then 7. So that's 7, and those together, that's going to be 11. All right, well, these are all positive. Nothing's going negative. Um, so 1 is the upper bound. These are all positive. So if one of them became negative or some other number that wasn't positive, obviously, we now if it is 0, you count that as a positive in this situation. But 1 is an upper bound or upper boundary. I think that's what he's really trying to say in here. Find a boundary. All right, so write these all down again, but this time we want to find the lower boundary or bound. So we'll start using numbers in the negative direction. So we'll start with -1. It's going to give us -1. That's going to that added together gives us -3, and then that -1 times -3 is 3, and that gives us 0. So we're starting to get zeros here. This added together is 2, and then that's going to be a -2. Add those together, we're going to get -5, and -1 times -5 is -5. And so add those together, we're going to get -1 times -5 is 5. Add those together, we get 9. But for the lower boundary, we need this to be every other one needs to be positive, negative, positive, negative. But a 0, oops, yeah, this wasn't supposed to be negative. But a 0 can count kind of as a plus or a minus. So this is a plus, this is a plus, this is a plus and minus, this is a plus, that's a minus, and that's a plus. That is definitely not every other one being plus, minus, plus, minus. So zip. This is not a boundary. -1 is not a negative boundary. So we have to try -2. And -2. So -2 times 1 is -2. So add those together, we get 2. And then -2 times 2. Well, we already have 2 pluses in a row. It doesn't go plus, minus, plus, minus. So 2 ain't working for us. Or -2 is not working for us. I can see this is 4, so let's just skip to 4. And the first one is 1. So -4 times 1 is going to give me -4, which gives me 0, which can be plus or minus. That gives me 0, which that gives me 3. And that gives me -12. Add those together, that gives me -10. And then -40, or sorry, +40. So that gives me 37. And then that is going to give me -148, which is going to give me -144. So here we have plus, and this can be plus or minus, remember. This is plus, that's minus, that's a plus, that's a minus. So they are alternating. So making that 0, counting it as a negative would mean plus, minus, plus, minus, plus, minus. So -4 is the lower bound. I'm just writing bound because I think it's funny. I think it's supposed to be boundary, but um, there you have it. I suppose to put this in a nice little box, we can just write these. The upper bound is equal to 1. The lower bound is going to be equal to -4. So equal 1 and -4. Put that in our cute little box and call it done. All right, so that's all the way through 36. Good luck on your test. I hope I explained those last few adequately. We haven't gone over those in class yet with our instructor or with the professor, so that's the way I remember those. So anyway, again, I'm not an instructor, just a teammate in the classroom with you guys, trying to figure this stuff out so we can get on to calculus. If you have any questions, leave them in the comments. Hit subscribe so you can see the next video for the next chapter reviews, all that kind of stuff. And hope you do well on the test. Thanks for watching.